So I'm Ben. I'm going to be talking about transforming Ruby code. And so an example of what this is, just so we're clear, here I have a for loop. And say I want to convert that into the .each forms. This is pretty much equivalent in Ruby. Let's say you wanted to go ahead and do this. So I'm going to be talking about some techniques for doing this kind of stuff, transforming your code into something else. And so there are a bunch of different applications for this. So first and foremost, you might want to do refactoring. So you could think of that first example as a refactoring, depending on which style you preferred. You could find instances in your code that weren't very idiomatic and sort of take those pieces and transform them automatically to do some automated refactoring. The second one isn't really transforming at all. This is just taking the code and putting it right back out without any changes. You could do some enforcement of coding style. So if you've got some code that's not formatted very well, or in your company you have specific coding standards, you could potentially enforce that or run it through a script to reformat your code to pretty print it out. The third one is sort of macro level transformation. So you could do conversions between different libraries, different DSLs. So a couple of good examples of this are going from test unit to RSpec, let's say. So they're very large-scale projects, and you could convert between them. Factory Girl, version 1 and version 2 of a different DSL is slightly different. So a lot of people are converting that by hand. You could automate this in theory as well. And the fourth one is kind of hits home to me, really because I tend to agonize a lot about technical choices. So I know that once I choose something, I'm going to be heavily invested in it. And once you go down that path, it might be costly to switch to another path. So that test unit RSpec is a great example. If you decide to do your test suite and test unit, and then 2 years later you decide, well, no, I really like RSpec better, that's really costly to do by hand right now. And so doing some automated transformation could help reduce that cost, I think. And so here's an example for anyone familiar with Factory Girl of Factory Girl 1 DSLs at the top and Factory Girl 2 DSLs at the bottom. So some people, when they approach this problem, the first thing that comes to mind as developers when you've got a big file or a string and you want to transform it is regular expressions. You go through, design a pretty complex regular expression, and you could hack something together to make that work. And for the first example, the for loop to .each, here's a possible solution. So in the middle, you could use that regular expression to achieve your goal, at least in that specific example. But this really is a false sense of security, because there's lots of things that will make this break. So see what I did there? So I just changed collection to the find call with arguments. But because it has a space in it, that regular expression is not going to work anymore. And so this really isn't a good way of doing transformations on code. It's simple, but it doesn't have any concept of syntax, the language. And it's very hard to approximate that with regular expressions. So what is the right way to go about transforming? And I think the right way is to do something called an AST transformation. How many people in here have ever heard of the term AST? OK, so if you have a computer science background, you might know what this is. I'll show some examples of this in the next slide. But basically, an AST stands for Abstract Syntax Tree. And it's a tree representation of your source code. So you can think of it as basically nested arrays, just a tree. And that this is, in fact, what the compiler and parser does initially when you run a Ruby program. The first thing it does is it's got to parse all your code into an AST before it does anything else. But we're just going to take that tree for what it is and do some stuff with it. So first, you can parse it. So it's getting the tree, data structure in Ruby. And then you can modify that using some different techniques. And then finally, and the most difficult part is once you have that transformed, you can reverse the parsing operation and try to deparse it or pretty print it out back into Ruby. So I'm going to go through these 3 different steps. But first, some examples of an AST in Ruby. Now, there are different sort of flavors of AST. I mean, every language has its own ASTs. The language has different semantics and different syntax. But I'm going to show you sort of one flavor of an AST for Ruby. But conceptually, I'm just showing it as a tree here. So 2 plus 3 in Ruby, you might know, is really just syntactic sugar for calling a method called plus on the 2 with an argument of 3. So it's the same thing. And so the AST for this is at the top level, you've got one node with a kind. In this case, it's calling a method, so call. And then you have children nodes, which have data necessary for that concept. So here, the first one is the object it's being called on, and the method name, and then any arguments. And so that's just a graphical form of an AST. A common form that you see this in is something called SExpression. And SExpression is really just the tree represented as nested arrays, whereby the first element in that array represents a type. So on the bottom right, you can see this is actually the AST for assigning foo equals 1. So this is just arrays in Ruby, nested arrays, and the first element is always a symbol that represents sort of the type of operation you're doing. And I'm showing the Ruby code here you're seeing is just a nice little abstraction. So rather than dealing with the arrays as an actual array object, you can subclass that into an SExpression class. And then you can call .kind, which will be the first one, or .body, which is the rest of the elements in the array. And on the right, you sometimes see the form, rather than actually using the square braces for an array, you'll see, you can define a method called s, which kind of just encapsulates that. And so instead of seeing the first square brace, you might see s parentheses. Okay, and a couple of examples. The bottom one I already showed you. This is the doing a local variable assignment. And in these examples, I'm highlighting in red what corresponds to the original source code. Again, there's the 2 plus 3. This is an actual Ruby AST that you get by parsing it. And so here we're, top level node call, and then you're calling on a literal of 2. And that third line is a plus. It's a method. And then finally an argument list. In this case, there's just one argument. There's a little more complex example. So if you do an if statement, this parses into a node called if. And then within if, the first part of that body is sort of the condition on the if. So here we're calling a method called a. And then the rest of the body is just the if it's true condition and if not condition. So that's what it will end up as. Okay, last example of this. This is it's really to show you that these do get complex quickly. So this is defining class with a method, and on the right is the AST we have. And note that there's actually some more information that doesn't really correspond to any specific token on the left, right? So we have a scope there. So class project nil, and then we have scope. So in the AST, it's actually encapsulating scoping rules in Ruby. So we have a scope node within there representing that scope. But you can see in red the pieces of the AST that match up to the code on the left. Okay, so that's an overview of ASTs. How do you get an AST? Well, you've got to parse the code to get that. You do that with a parser, and there's different parsing tools. Of course, every language has their own parsing tools. There's 3 popular ones in Ruby right now. There are a couple other ones. I'd say these are the most widely used. The first 2 are very similar. They're both Seattle RB projects by primarily Ryan Davis. And really the only difference between those 2 is that Ruby parser is pure Ruby, and parse trees is a C extension. They both emit the same flavor of AST. And that's the flavor that I've been showing you in the examples. So limitation of the first 2, however, is that they only parse 1.8 syntax. And notice I said 1.8 syntax, not code, because you could, in theory, have a program that's Ruby 1.9, but doesn't use the 1.9 syntax features, and so they would still be able to parse that. This is a big limitation, but I think Ryan Davis has actually put out a bounty for fixing bugs to get the test passing a 1.9 for Ruby parsers. So I think that will be imminent, and we'll be able to parse 1.9 code. The third, called Ripper, is basically an internal parser exposed via Ruby 1.9, MRI 1.9. And this is the actual parser it uses, and it's exposed to you via the Ripper class that you can use. It's great. The problem right now is that it's very buggy in 1.9.2. So to the point, I think, of probably not being usable for this stuff. So 1.9.2, Ripper, still a lot of bugs. The good news is that all or most of the bugs have been fixed in 1.9.3, which just came out last week, 2 weeks ago. So as of 1.9.3, Ripper's kind of ready for prime time. But these are kind of the three main parsing tools that people use. OK, so once you've got the AST, it's all parsed. You've got your data structure. Now you want to transform it. So how would you go about transforming that? And you could probably think of some ways, once you had an example, to go through and use some if conditions to kind of hack up that series of nested arrays. But there's a cool little pattern for doing this that I think encapsulates transformations really well. It's called the tree walker pattern. And basically, the tree walker pattern is a class implementing one method that's essentially recursive. So it starts at the root node of the AST, and it will basically walk down through all the children and call that method again on those children. And the point of this is that this method, in this case we're calling it transform, the method is supposed to return the AST you want to replace it with. So for any given node that's called with the argument, it's going to return a replacement. And that replacement could be something different if you're doing a transformation, or you could just return it unchanged. So if you return unchanged, it's going to walk through the entire tree and collapse back up into the original AST. But and that's, in fact, what this example does. This is a base class, so this doesn't do anything except return the SExpression you gave it. But you can subclass this, implement the transform method, and that's how you can start to do transformations, is by overriding it. OK, so let's look at a couple of examples using that tree walker pattern, just simple examples. So here's the first one from my first slide, converting the for loop into a dot each. And indeed, in the Ruby AST, there is a node type of for the for loop. And for the dot each, it's really just a call. You're just calling a method on an object. So we want to transform the first AST into the second. So here's what this might look like using the transform as a base class. So you see I'm implementing the transform method. In this case, I'm just I'm making sure that the super method gets called, but I'm going to just delegate it to this second method called transform force to eaches. And the general pattern for doing this is what you want to do two things. You want to first match on something. So you only want to transform what you expect to be transforming, so you're going to match on that. In this case, we're matching just for the for. You want to find any AST node that has a kind of for. And then if it matches, you want to transform it. If it doesn't match, then you just want to return it unchanged. So that's what we're doing here. You see the third method is basically building a new AST from scratch, and it's just plugging in the body of that for loop into that AST. So you see they have the call, and then it's going to call it on the collection that you were using the for loop for, and just put that body right in there. And so that's how you can do a transformation from top to the bottom. Okay, another example. Let's say you want to do a transformation to find any method that explicitly returns at the end. So in Ruby, this is not necessary. Setting aside for a moment whether you may or may not want to do this, let's assume you do, and design a transformation to check for that case and then take out the return. This is another good example of where using a regular expression might be tempting. Oh, I can just replace return with empty string, but there's a lot of cases where that's going to break. This is a little more involved. Here we're going to match. So the third method is doing the matching. And in this case, we're checking first and foremost, is this node a method? If it's a method, does it have a block? If it has the block, does it actually have a last line? And then finally, is that last line a return node? right? So that'll match for cases where you have a method, but the last line in it is actually returning. And so when it matches, it's going to go down to the bottom. And there's a couple different ways you could do this, of course. In this case, I'm basically taking the original AST, and I'm going to clone it, but I'm going to just take the last line, and I'm basically going to replace that return node with the contents of the return node. So I'm just removing that return from the method. Okay, I don't have a code example for this, but just to give you some other ideas of very micro-level transformations you could do. So this is a common idiom in either Ruby 1.9 or active support. So if you're doing a .map or .collect, and you're just calling a method on that, you got this little trick that uses symbol to proc to make that a little more clean. So you could design a transformation that looked for instances of calling these things and found where, well, you're only calling one method inside there, and do the AST transformation to convert that. Another example, this is something I do a fair amount in just refactoring code. Instances where in a method you're defining a local variable for no other purpose than to do something with it and return it. So the first line, you're just kind of initializing it. The last line, you're just returning it. This is a little contrived example, but some more complex methods, it probably makes more sense. But you can use the .tap method to kind of give it a little better structure. I kind of prefer that approach. So you could design a transformation to go through and look for those cases and transform it. The transformation for this, I've written the transformation for this, but it's pretty long. It's a little more involved. But you can look at the code if you're interested. If you want to do a sort of one-off transformation, I've got a class called custom I built where you just give it a block, and that basically is like defining the transform method. And in this crazy example, we're basically finding any string, and we're going to reverse it. So if you run this as someone's code, it'll reverse all the string literals in their code. Could be a fun prank, maybe. OK, so now that you've got to transform, the final step is to deparse it. And this is by far the most difficult part. And this is, I think, why people aren't actually doing this in practice. I mean, you don't see too many people writing transformations and doing real transformations with their code. It's because the deparsing is very difficult. And that's because you lose information. When you parse the code, you're losing all the white space information. You're losing things like the quoting style. One thing you lose is the block style even. So if you had a block in your code, you can't tell from the AST whether that was originally a do-end style block or just a brace. So that's a challenge to try to deparse if you don't know what it was originally. Depending on the parser you're using, you might lose even line number and comment information. A Ruby parser will retain comments so long as they are before a method or before a class or module. So in other words, it doesn't retain comments inside a method, but it will retain other comments. So these are all problems for doing deparsing. But there are deparsers out there. Here are, well, the first two are popular. The third one is my project. But I'll talk about the first two briefly. Ruby to Ruby's been out for a while. This is basically the sister project to Ruby Parser. So Ruby Parser parses, Ruby to Ruby deparses, or pretty prints out the code. And this has the same challenge that it's essentially Ruby 1.8 only, because it's operating on the Ruby parser AST. But a real problem that I ran into with this, and what I think impedes it from being of practical use, is that it doesn't really make any attempt to try to format your code as you would format it yourself. So it'll output it. It'll do indentation. It's a complete implementation. The code will work, but it's not going to look pretty. It's not going to be code that you're going to want to sort of commit anywhere without cleaning it up and making it formatted a little bit better. So that's a challenge, I think. That's the main challenge with using this in practice, is that you're not going to take your Hughes Ruby file and then transform it and then output it, and then it's going to look like crap, because then you had to go through and change everything anyways. The second project is one that I haven't looked into too much. This is a new project that's operating on the Ripper AST format. similar to Ruby, I think falls pretty much the same problem, where it is a, will output working code, but it's not formatted particularly well. And so in trying to use these, I was frustrated with getting the output I was getting. And so I created the third one. It's called Ruby Scribe. And it's a deparser similar to Ruby. It's a complete implementation. But it tries to do a lot of things to intelligently format your code. So it'll intelligently put in blank new lines where most Ruby programmers put in blank new lines. It won't use parentheses in certain methods, like require, that most people don't use parentheses for. It will try to figure out whether you used the brace style block or the do-end style block based on the complexity of the contents of it. So if it's very simple, then you could probably do it in one line, so it's going to use a brace. Otherwise, it'll use the do-end. And so it does these kind of things to intelligently format your code. And it's also configurable. You can, to some extent, configure it to your own coding standards if you like to do things a certain way. And so if you use Ruby Scribe, or any of these really, without transforming the code, it just turns it into a code formatter. So you can take really crappily formatted code, just don't change it at all, and just run it right back to the deparser, and it will output, hopefully, well-factored code from a style perspective. Okay, and so here's an example. So this is valid Ruby, completely working. It's just not formatted very well. It's formatted very poorly, actually. And so if you run this through Ruby Scribe without changing it, there's AST for it, you'll get this. And so that's how I think most Ruby programmers would format their code if they were going to change this example. And so, so one of the interesting things is when I was going about developing this project, you have to make certain decisions about what it's going to do. So really opinions as to how you format your code. And so what I did was basically use the Rails code base as the definitive source of coding standard. So it's not perfect, or there are inconsistencies even with that code base, but I'm using that. And then basically I'm running Ruby Scribe through every single .rb file in the Rails code base without it being transformed. I'm just overwriting the original file. And then what that lets me do is I can run a git diff. I can just get a diff of basically what the original was versus what Ruby Scribe outputted. And while refining it, basically the smaller that diff, the better, more or less. And so that's how you get code. That's how you get these ASTs back out to real Ruby code. Now, there's still some problems with this, and this is still fairly new. I'm not sure it's ready for large-scale use. We've got sort of this problem where we've got different AST flavors. We've got the Ruby parser flavor. You've got Ripper flavor AST, and I think Rubinius uses yet another sort of AST. So I think going forward, kind of the standard AST format will be Ripper once Ruby 1.9.3 is more widely adopted, because the bugs are fixed there. So once we can standardize on that, then we can move these tools to using that AST, and it will all work with 1.9. So we're waiting on that. Deparsing could get even better, I think. It would be pretty cool to also do matching a little more elegantly than just doing a bunch of Boolean if conditions. It's kind of ugly. It'd be cool to just have some sort of like regular expression for trees where you could match into trees. And finally, all the examples I've been showing you are basically using SExpressions, which are just nested arrays. Working with them is a little bit difficult. You could, in theory, instead have an object-oriented model of the AST, and it might be architected a little bit better. So finally, I'm going to show you two potentially real-world use cases. And these are more just proofs of concept for now. I wouldn't use these on your actual code yet, because I haven't implemented a whole lot from it. But the first project is called RSpecify, and so this basically does a bunch of transformations to convert your test unit to RSpec. I should put big quotes around that, because when I say convert, I'm not saying it's going to end up being perfect. Certainly, there's a lot of decisions that need to go into converting that. But I think you can get 90% of the way there, all the tedious stuff, by letting the computer do it. You know, we humans shouldn't have to go through and hack up this stuff that it has defined rules. And so the code on the left, if you run it through RSpecify, will be wound up as the code on the right. So I'm working on implementing some more matchers for this. Basically, I've got to do transformations for every matcher into the RSpec form. But it's a proof of concept for now, something that could be useful down the line. And the second one I alluded to earlier was a factory girl. So if you've got a bunch of factories in the version 1 DSL, want to convert them to version 2, there's a project up called Factory Girl Upgrader, which will do that through transformations. And I talked a bit to Joe Ferris, who's the author of Factory Girl, and he's been working on basically regular expressions to do this, or maybe Vim macros. And so he was excited to see, you know, the potential for doing this, making sure it works 100% by getting the AST and doing it this way. And so, yeah, so that's AST transformation. This is the last slide. This is potential for the future, something I've been thinking about and that I'm kind of interested in. It's obviously a huge amount of potential work. But in theory, if you can transform ASTs within Ruby, you should be able to translate them between languages. This works best when you're going from one language of semantics that can be represented by the target language of semantics. So I think most of the semantics in Ruby we can approximate in Ruby. Most of the semantics in Java we can approximate in Ruby fairly well. So this is a potential. So you could, in theory, parse the Java AST. You could translate that Java AST into the Ruby-flavored AST. And then from there, you could do some transformations to look for cases where you can make it a little more idiomatic. Like in Java, you tend to use temporary variables and use loops to do a lot of things. And in Ruby, we have a one-line form like .map or .inject. So you could apply those transformations to kind of refactor it on the fly, and finally deparse that out into Ruby. And it would, in theory, be fairly working JRuby. So the key here is that we can leverage JRuby to not have to translate basically the standard library and all the class references. So any class references that we were using in the original Java code, we can just take right through. It'll just be in Ruby. It'll be using JRuby to access those in the JVM. So this is kind of interesting. I think it'd be a lot of work, but I think it'd be cool to see some more of the stuff done in the future, actual language translation. And OK, so that's it. Some of the projects I mentioned are here in GitHub. So the first one's Ruby Scribe that I talked about. Ruby Transform is just basically a simple class that defines that true walker pattern. It's not super useful. I mean, you could just write your own class, but I have it up there for reference. And then the last two are examples of these transformations. So that's it. Any questions?
So I've done a fair amount of these refactoring passes that involve regular expressions or whatever, scripts that get more and more sophisticated. The thing that I find is actually the difficulty is not in writing the transformation, it's actually in performing the quality control afterwards. So the key is actually to see a diff and for it not to have changed every line that in superficial ways.
Right.
And I'm wondering how much of that, because of the way that the AST transformation really completely writes that. I mean, unless your code started out normalized by that into an AST deparsed format in the first place, how much that increases the demands upon you for quality control when you do something like transform the factory girl from 1 to 2.
Yeah. So okay, that's a good point. And I think the point you bring up was actually the problem that I was really running into before Ruby Scribe. So what used to happen is I would have my code. Let's say I had a file full of factories. And it was formatted nicely, or at least the way I like to format code. And if I were to do that transformation and print it back out via Ruby to Ruby, the problem is that the output is really nowhere near diffable because it's not formatted right. So I look at that diff, and I can't tell exactly what's being changed because the indentation's wrong or there's not white space appropriately. So the point of Ruby Scribe is to try to approximate what you likely formatted the code as to begin with. And in doing so, you end up with small diffs, which is nice. So when you do the transforms, a better example are sort of the smaller ones, like maybe they're removing the return, right? So that's a good one where if you do that, what you'd really like to see is just a diff that just has the minus line with return and the plus with that and nothing more, right? And so the better that the deparser gets at approximating your original code, the better that is. Now that being said, you raise a good point whereby that really depends on how close your code format is to what Ruby Scribe outputs.
Well, maybe you could actually deparse this to start off with and do a one-to-one, basically just reformat it and then run the diff later.
Yes, totally. Yeah, if you just wanted to look at what the transformer is doing, that's a great point. So you take your code, you run it through Ruby Scribe to kind of normalize it, right? And then you do the transform, and then you output it again, and then that diff should be very clean. You should only see what's being transformed. Yeah.
Neat presentation, man.
Thanks.
Yeah. Kind of piggybacking off of that, what did you see when you ran it through the Rails code base?
Yeah. So that was. Let me tell you, the first time I did that, it was an enormous diff, as you might imagine, because when I first started Ruby Scribe, I was basically just doing two things. I wasn't going to use parentheses in certain methods like require. And I was going to try to do empty lines, like before class definitions, stuff like that. And so there's a lot of differences between them. And so in refining it, I basically just iterated over getting that diff smaller and smaller. And I found instances in the Rails code. It's like, oh yeah, that makes sense. I should probably code that in as a special case for how it's being formatted. And so I do that, and then it disappears from the diff. And you just do that over and over and over again until you get the diff fairly small. I think the diff at this point is about 15% of the original code, which means that Ruby Scribe is approximating, of actual Ruby lines, non-comment lines, it's approximating about 85% of the committers to the Rails code base's coding style. But it's always getting that last bit is always very difficult. And there's even some inconsistency in the Rails code base. Like in some instances, Ruby Scribe is emitting what I would think is better code than what's in the code base, because there's some inconsistency in the way that different committers are formatting code and so on. But I have not tried to run it into other projects. There are other big projects.
It kind of seems like, it kind of seems like Rails would be almost a harder project to run it against because there are so many committers, there are so many different.
That's a good point. Yeah. Now I think there's a coding standards document that people are supposed to adhere to, but that's a good point. I mean, you could probably look at maybe a ThoughtBot project that is very consistent. I mean, with almost no exceptions, coding style, and it might work out better with that. Yeah. The nice thing about using Rails, though, is that it is so exhaustive. Now, you run into every possible formatting situation you can imagine because it's just such a large code base.
So the idea is that eventually you'll be able to actually configure it for your own style. Would it make sense to have almost a learning system where you could basically give it your code base and say, learn what my style is, or is that just insane?
No, that is, it's not insane. It's very difficult. Basically, to do something like that, I mean, it would sort of be possible. You'd have to parse AST and then write a lot of complicated stuff to sort of compare the AST to the original code, sort of looking at where you do new lines and stuff. It would be possible. That's kind of interesting, is to have it learn your coding standards. What gets really difficult is that it's not of much use unless you're consistent. So if you've got inconsistencies in the way you do certain things, then it might be hard. But.
So I don't know if you saw the laser talk.
Yeah, I did. I went to that.
So,
yeah.
I mean, Michael had said that it's very still in kind of the academic phase. It's slow to run. It's buggy, and it's a very ambitious project as like a Ruby lint type project. But I can see, you know, like in terms of like the low-hanging fruit, like hitting runtime errors around like wrong arguments or, you know, random little things like that. I could see using a smaller version, but with, you know, a syntax parser like this to find those cases. Is there anything underway like that? Or?
No. So okay. So you bring up a good point about lasers. So for those of you who don't know, laser is a static analysis tool. It does some pretty. It's a very impressive project. It does some pretty crazy things to try to dig real deep into your code and analyze it, and show you things that you might be doing wrong or might be bad practices or so on. Now, laser goes way beyond analyzing the AST. So here we're looking at the AST, and you could think of some ways to go through and rather than transforming it, just kind of analyze what's there. Laser is doing that to some extent, but it's also it's actually running your code. It's basically consulting the object heap in Ruby to look at the objects that are being defined and so on. And it does some pretty crazy stuff. But you could do something much simpler just by looking at the AST itself and doing some analysis on that. Even just, you know, let's say you have a programmer that uses camel case for his names. You could analyze all that from the AST.
Yeah, I mean, I would just think of it as like having a very small subset of features to catch like runtime issues, but, you know, in the sense that maybe you can run it when you save a file or something.
Yeah.
Like a fly make type thing.
Yeah, yeah. I mean, some of that. Yeah. So a lot of that you probably could do with just AST. I mean, even the AST shows you the scoping rules. So you could kind of. There's kind of a fine line between doing that and actually re-implementing the semantics of the language, you know, and sort of keeping track of all the variables and stuff. But you could do some of that stuff for sure. Yeah.
And I don't know if you mentioned this, apologize if you did, but what type of like speed are you seeing in terms of like when you're doing the Rails, when you're running this against Rails, what kinds of, I mean, I could imagine it's pretty intensive, so.
Yeah, it is. I think the most intensive part isn't deparsing or, well, there is no transforming. The most intensive part is the parsing. I haven't done benchmarks on it, but I would imagine the vast majority of the time spent in that is Ruby parser. So I've been using Ruby parser, which is pure Ruby, and it's slow. If I use parse tree, it would be significantly faster, because parse tree is basically C. It's almost entirely C that does the parsing. But I think, I mean, when I do it against the Rails code base, it takes maybe, I don't know, like 20, 30 seconds. So it's not too long. There's a lot of files in there.
That's pretty good, yeah.
Yeah.
Hey, great talk. So where do you get like the schema for the syntax nodes?
Oh.
Well, how do you figure out? I saw, you know, there was that example that showed the scoping rule, and it was defining a class at the top level. So it was the type was class, then it had the class name next, and then it had a nil. And I was thinking the nil must be a subclassing sort of call or something like that.
Well, it's that, yeah. So there is. I mentioned there's different flavors of ASTs. So each flavor is kind of defined by, given a concept, how is this represented in the AST? And even to the point of what you call the types. So, you know, what do you call an if? Well, it could be if. What do you call it? What do you call a local variable assign, right? What's the actual name for that? Now, in the AST we looked at, it's LASGN, but, you know, it could be whatever, right? So Xavier's asking, you know, where did that all sort of come from? Like, what is the definition for what this AST is? And the way I learned it was actually just looking at Ruby parser. So Ruby parser and parse tree emit the same AST, and they use a pattern where they basically, you know, the code's tokenized, and then it basically, every time it catches a token, it will call a method with the name of that token. And I sort of just read the source code to figure out how it was building the AST. So that way I could know how to reverse the operation. But to my, I don't think there is sort of a documentation or schema definition for that flavor of AST. Yeah, no, Ripper uses a completely different flavor. And Ripper AST is a whole object-oriented model, actually. So you've got instances of node with subclasses and all that. Now you can represent that as an SExpression, but even that is of a different flavor than what Ruby parser is doing. And that, I think, is a little more well-defined. I took a bit of a look at it in the code base, but I haven't done a whole lot with Ripper.
Have you considered writing your programs in the AST and skipping writing it in Ruby? Thanks.
Always a joke. It's called Lisp. Great. Anybody else?
All right, thanks.